Hello class 10. In this video we are going to work on some problems on combination of resistors. So we have this combination of resistors over here. The picture may not be very perfect, okay, but still it'll help us solve the problem. So we have a combination of 1, 2, 3, 4, 5 resistors over here, and we are to find the equivalent resistance between points A and B. So how do we proceed? So you can see, let us start from above over here. So you can see this is a resistor of 3 ohms and resistor of 2 ohms. So these two resistors of 3 and 2 ohms, they are connected end to end. The end of 3 ohms is connected to the end of 2 ohms, one end of 2 ohms of course. Okay, so 3 ohms and 2 ohms, they are in series. Okay, so the equivalent resistance of these two is 5 ohms because 3 plus 2 ohms is 5 ohms. So you have, it's like you have a resistance of 5 ohms over here, and to the equivalent of these two is connected 30 ohms. So you have 30 ohms over here. So this is 30 ohms, and of course to the junction of these two is connected these two resistors again. Now again, if you check the resistance of 6 ohm and 4 ohms, one end of 6 ohm is connected to one end of 4 ohms, so which means these two are also in series, and 6 ohms plus 4 ohms, since they are in series, it's equal to 10 ohms. So we have, it's like we have 3 resistors connected in this fashion. This is a point A, this is a point B, or for convenience you can also consider point A to be this and point B to be this. Now we see that the equivalent of these two, which is 5 ohms, the end of the two ends of 5 ohms is connected to the same two junctions, is connected to the 2 ohms of 30 ohms, alright, and the two ends of 10 ohms is connected to the same two junction here. Alright, so to say, these 3 resistors, as you can make out from the picture also, they are in parallel. Okay, so how do you find the equivalent resistance? So equivalent resistance in parallel, let's call this R1, let's call this R2, and this is our R3. So 1 by R1 plus 1 by R2 plus 1 by R3. So I will only tell you the physics part, how to solve it, okay? So you will substitute their values, of course, and you do the mathematics and you will get the value of the equivalent resistance. Mind you, equivalent resistance is not 1 by Rp, it is simply Rp. So you need to find the value of Rp. Okay, so this is how you do this problem. Then there is another problem, so where we have, okay. So let me erase this. So there is this problem where we have one resistor over here, another resistor over here, another resistor over here, and we have one resistor here and another resistor connected there, and we need to find the equivalent resistance between points A and B. The thing given is all of these resistors have the same value of resistance, which is 3 ohms. Okay, so where do we start? Let's start over here. Now one end of this 3 ohm is connected to the other end, or is connected to one end of the second 3 ohm resistor, so which means these two should be in series. Alright, so this picture can be redrawn this way. So this is our point B, this is our point A, and here is we have the equivalent resistance of these two. So since these two are in series, 3 ohms plus 3 ohms is 6 ohms. This is 6 ohms, this is 3 ohms, this is 3 ohms, this is 3 ohms. Now what will you do? What we will do is, since we see these two resistors are in parallel, the two ends of 6 ohm is connected to the same 2 points where the two ends of this lower 3 ohm resistor is connected. So these two ends of both the resistors are connected to the same junction, so which means they are in parallel. So if we say 1 by Rp is the parallel combination of these two, then 1 by Rp will be 1 by 3 ohms plus 1 by 6 ohms. Okay, you can do the mathematics. Let me do at least this for you. So this is 6 ohms, the LCM. I can do away with the unit for now, ohm. So this will be 2 plus 1 in the numerator. This will be 3 by 6 ohms. Oh, sorry, yeah, ohm in the denominator. So this is equal to half ohm in the denominator, of course. So 1 by Rp is 1 by 2 ohm. So therefore Rp is how much? Rp is 2 ohms. Okay, so the equivalent of these two is 2 ohms. So the picture finally becomes, so I'm drawing 3 different pictures just to make you understand. You don't have to go on drawing these pictures. Okay, you don't have to go on showing these pictures again and again. So we have 3 ohms over here. This is now 2 ohms. The equivalent of these two is 2 ohms, and this is 3 ohms again. Now we see these 3 are in series. This is point A, this is point B, and therefore 3 ohm plus 2 ohms is 5 ohms, plus 3 ohms is 8 ohms. So thereby, the equivalent resistance of this picture in between point A and point B, the equivalent resistance of these combination of resistors, to be more specific, therefore is 8 ohms. Okay, so this is how you do these problems, remember. It won't be very difficult if you understand how to check which one is in parallel and which one is in series. If you understand that much, you know the mathematics shouldn't be much, very difficult for you all. Let me do one more problem for you all. You will get this kind of problems, okay, from combination of resistors to find the equivalent resistance. Those are the most difficult kind of, it seems. That's there in the book, of course. So you have this picture and you're asked to find the equivalent resistance between point A and point B. The values of the resistances are 2 ohms, 2 ohms, this is also 2 ohm, and this is also 2 ohm. Now where do we start? We start from here. Now we see these two are in parallel, so we'll find the equivalent resistance. So equivalent resistance of these two resistances is given by 1 by Rp, which is 1 by 2 ohm plus 1 by 2 ohm. Okay, so 1 plus 1 becomes 2 by 2, so this is 1 by 1 ohm rather. So therefore Rp, the equivalent resistance is 1 ohm simply. So equivalent of these two is 1 ohm. So to say this picture can be redrawn this way. So the equivalent, this is the equivalent of these two, which we've got to be 1 ohm. This is 2 ohms. This is 2 ohms. This is point A. This is point B. So the equivalent resistance between point A and B is 2 ohm plus 2 ohm plus 1 ohm, which is 5 ohms. Alright, class 10. So I think this will give you some idea at least, and this is how you proceed regarding combination of resistors.